Hi, and welcome to the second lecture. We really spent some time last time just introducing the basics of MATLAB, the very basics, really. Um, so as we continue on, we're going to get into a little more details, a little more of the usefulness of the different features that MATLAB has. So what I want to do today in today's lecture is spend some time dealing with arrays. And either towards the end of this lecture and the beginning of the next one, I like to get into the uses of scripts, which is one of the most powerful features in MATLAB. And it won't be a complicated script, but at least it'll give you an idea of some of the major uses that you can find for MATLAB. So let's just get started. Let me share my screen here and get into the system. And just put that out of your way. And of course, this is our desktop. And let's say we want to create an array of size 1 by 5. And I want to have the numbers between 0 and 3. So an array, the size is 1 by 5, and I want numbers between 0 and 3. Now, we can make use of the ran function. And the ran function simply generates numbers given a size that you give it. For instance, if I say, let's make z equals ran, R-A-N-D, and in parentheses, we're going to have the size of the array I want. So let's say I want a 1 by 3 array of random numbers. So doing this, the function ran generates the vector array of 1 by 3 of 3 random numbers. And you can do the same thing for any number of random numbers that you have, that you want, 1 by 8, 3 by 8, and so forth, right? That gives you just a random array of any numbers you define, of the size you define. But then, like I said, if I want to generate a array of random numbers between 1 and 5, I'm sorry, between 0 and 3 of size 1 by 5, then all I have to do is simply multiply the number of the array by 3. So that will give me 3 times ran 1 comma 5. So the ran 1 comma 5 generates, the array, right? A 1 by 5 array. And then multiplied by 3 will constrict those numbers to be between 0 and 3. So there you have it. You have an array of random numbers between 0 and 3 of size 1, 5. So now let's say that I want to create an array of size 1 by 5 again with random numbers between 2 and 5. Well, I can do basically the same thing by just manipulating what I had previously. So if I add 2 to this expression, now I have numbers between 2 and 5, right? By just adding that 2. So this is how you create and manipulate arrays, right? Of sizes that you want with the information you want in it. So now let's say that, again, if I want to create an array of size 1 by 5, but this time I want numbers between -2 and 3. So again, I can manipulate that same function. This time I'm going to multiply by 5, and I'm going to subtract 2 because now I want numbers between -2 and 3. So by doing that, now I have numbers that range between -2 and 3. And again, anytime I run the function, it's going to write different numbers because it's giving you a random numbers. Okay. All right. And I think last time I also mentioned about generating numbers within certain range and having a specific number of steps, right? By using the the column feature. So for instance, if we have x equals 1, column 7, could equal 1, column 7, I have, generated numbers from 1 to 7. If I don't give a step, if there's not step in between the 1 and the 7, it means that it's just going to increment by 1. Okay, that's the default. If I want to increment or create a numbers in an array from 1 to 7, but I want to have a step of 2, then I'll have a 2 as a step. And so this is my beginning number. The array is going to begin at 1 and it's going to end at 7. Or it's going to have a maximum of 7, but it's going to increment in steps of 2. Okay, so it's going to go 1, 3, 5, and 7, as you can tell. I can do the same thing if I want the increment to be 3, or the step to be 3. Now I have only 3 numbers because I have 1 plus 4. 1 plus 3 is 4, and 4 plus 3 is 7. Okay. Now let's say I want to have an array of numbers that range from -1 to 5, again with the step increment of 2. So, but this time again, I want to go from -1. So I'm going to start -1 until I get to 5. But again, I want the increment or the step to be 2. So again, this is the starting number. It's going to start at -1. It's going to have a maximum up to 5, and it's going to increment in steps of 2. So now again, I have -1 through 5 in increments of 2. Okay. In the same fashion, I can generate steps that are non-integers. For instance, if I want to go from 0.1 to 3, so if I want to go from 0.1 to 3 in steps of 0.2, then I can simply do this, right? So I want to go from 0.1, so that's the starting point. So the last number I'm going to have is 3, because that's the maximum I want to go. Then I want to go in steps of 0.2. So there you go. You go from 0.1 up to the maximum will be 3 in steps of 0.2. Now notice here that obviously we didn't get to 3, because if I add 2.9 plus the step of 0.2, you will then get to 3.1, and that's not in the maximum range. So in this case, the array is going to generate a maximum number of 2.9. Okay. Again, because the maximum that I want is 3, and because of the step, I'm not going to get there. Now, let's see if you can try this on your own. Try to generate numbers from 5 down to 1 with a step of -1. So we want numbers, sorry. You want numbers from 5 down to 1 in steps of -1. So you can pause the video again, and you can try to generate that on your own. You can either write it down, or if you have your computer, you can try it live in your system. So numbers from 5 down to 1 in steps of -1. Now, since I'm going down this time and I'm going up, right, meaning that I'm going to start at 5 and I'm going to end at 1. So then that means that the increment is going to have to be -1, or the step is going to have to be -1, right? So I can do that very simply by just, again, defining my initial number is 5. I'm going to go in steps of -1 until I get to 1. And that's all it takes, right? So you go from -5 up to 1 instead, 1 instead of -1. All right, let's try another one. Again, see if you can try that on your own before I type the solution on the screen. So now we want numbers from -3 to -5. So starting from -3 down to -5 and with a step of -0.02. Okay, so from -3 to -5 in steps of -0.2. Okay, stop the video, give it a try, and then I'll show you the solution right here. So what we're going to do is I'm going to define again from -3 in steps of -0.2 up to -5. And again, I'm decreasing, right, because these are negative numbers. And so there you go, right, from -3, right, up to -5 in steps of 0.2. All right, excuse me. The other thing I want to show you is how you do the transpose of an array, right? So if I have a number, if I have this array, simply defined by, numbers like this, right? And as I know, if I define this variable x, I have an array of 5 numbers, a 1 by 5. And if I add simply this, end of the quote, right, single quote, to the end of the vector, I generate a column vector then. It gives me the transpose of x by simply adding this. I get a transpose of the vector, okay? Now, again, you still get 5 numbers, right? The transpose doesn't change that. But the difference now is that the size, right, instead of, with the first case here, I have a 1 by 5, and in the case here, I have a 5 by 1, right? Number of columns, number of rows. Remember, the first number is the number of rows, and the second number is the number of columns. Okay. All right. Now let's talk about some operations. And I think I mentioned this before. When you operate with vectors, you have to use a period, right? Otherwise, the system is going to think it's dealing with a scalar number, right? If you have just scalar numbers, let's say I define c equals 2 and d equals 7, right? So if I simply multiply those two numbers, c times d, you know what you're going to get, right? Or c into d, right? Remember the backslash, I'm dividing 7 into 2. So doing that, I'm basically dealing with scalar numbers, right? I don't have to have a period when I use these operations or these operators. But if I'm using arrays, I'm going to have to be careful and have that dot, and I'll show you that in a minute. So let's define 2 arrays. Let me clear this. And I'm going to define 2 arrays. First array is x, and it's given by the values 1, 2, and 7. And the second one I'm going to define is y, and y is defined by the numbers -2, 3, and 8. Okay, those are my 2 arrays. Okay, so if I do just x plus y, oops. You remember that it's not storing the result anywhere, even though you get the answer, right? It's not storing the result in any variable. So unless I define a variable, it's going to store that number or the result in that variable, right? So now it's stored. You can see here actually created that array, right here, or that number z, which is now storing the result of adding x plus y. But if I don't assign anything, it's not going to store. It's still going to give you the answer, but it's not going to store it anywhere. Okay. It's just temporarily in the default variable answer, a and s, but it's a temporary result. Okay. Element, when you multiply elements in two arrays, you definitely need to have the dot before the actual operator, in this case, the multiplication. So if I do x, say if I don't do it, right, multiply x times y, okay, and remember, x is a vector, y is a vector, so you get an error, okay. You get an error because it's expecting to see that dot here before the operator. So if I place the dot before the operator, then it's going to give me the result that I was expecting. Okay, you know, it's just something to remember. The same thing when you do division, right? If I do division, I try to divide x over y, I'm going to get a number that is not really what I was looking for, right? Because it's not dividing the arrays, right? Instead, if I do this and divide by y, oops, notice that I got an error because I did it backwards, which is a good thing to, I had an extra operator in there. So now I have what I was expecting, right? Which is dividing each of the values in x, divided by each of the values of y, right? Which is what I was expecting to do. All right. We can also do more complex or multiple operations in one step if I wanted to. Click this. So I can do things like if I want to add x and y, and I can do that in the same line, okay? And I'm going to then multiply by the following products, right? Multiply x plus y, and I'm going to keep multiplying if I need to, if I want to. And I'm going to plug in by x and by x plus 3, right? So you notice here that even though I don't have parentheses in this expression, okay, I have to follow the order of operations. And I gave you the orders of operations in lecture 1, where parentheses take place first, and then multiplication and division, and then addition and subtraction. So in this case, even though I'm not using parentheses anywhere here, you know, because of the order of operations, parentheses came first, then the multiplication came second, and then any addition and subtraction came last. Okay. All right. We can also let's add, or let's create another array, 1, 2, 5, and I can change the values in that array by simply adding, you know, if I want to add a number to the new x, I can add x plus 4, and then every number inside will be incremented by 4. Okay. I can also look at any individual value in the index of that array. For instance, if I just want to know what the first element in that array is, I can just subtract it by putting that index in parentheses, and you start with the index 1, 2, and 3, and so forth. If I want the third element in that array, I can simply get it by putting a number in parentheses for the corresponding vector. Again, adding, subtracting, or doing anything to the vector that you want is just simply a matter of creating the operation that you want. If I want to multiply the array by the numbers, by the number 4, every number in the array will be multiplied by the number 4, right? But the latest, the latest that I have in X will be multiplied by the number 4. So operations are very easy that way. Okay. And remember, you can do any operation, including if I want to, for addition and subtraction, remember, you just add the number to the array very easily, okay? But you can also combine arrays by what is called concatenation, concatenating an array. And so let's remember what we have for X, and let's remember what we have for Y. Okay, so I can create an array, the Z, that combine those two arrays by the feature called concatenation, by simply following X, the values of X and the numbers of Y in the new array. So if I do that, then my new array will simply be the values of X, right? The values of X followed by the values of Y, which creates my new array. Again, I can do, if that's not what I wanted, if I wanted Y first and X second, then obviously I can just reverse the order in which they appear, and I have a new array with now Y being first and X being second. It's just manipulating the arrays in all those ways, okay? So, now you got to be careful when you try to concatenate the two arrays because the number of rows have to match. If they don't match, then you're going to get an error. For example, if I do X equals 1, 2, 3, 4, and then I create another array Y equals to 3, 5, 6. Okay, and then I try to concatenate those two, right? If I do this, well, I can simply go to my max commands, and if I try to do this, I get something that is not really what I was expecting, right? Because now the two numbers, let me just show you something here. Sorry, in this last one was trying to show you that the rows didn't match, but I didn't have I have to first convert that Y into a column so that they won't match, right? So in other words, X is still, let's look at X, right? This is X, and this is Y, right? So this is a 1 by 4, and this is a 1 by 3. So yeah, the number of rows match. So that's why, this is fine. But if I change the number of rows in Y, so if I do this now, instead, if I create this array, 3, 5, 6, but I change the order of the columns and the rows, right now I have a 3 by 1. So if I try to do what I was saying before, then you get an error because you're not matching the number of rows. The number of rows have to match for that operation of concatenation to take place. Okay. All right. Let's continue with the creation of arrays. Okay. So now some more examples of array manipulations. You can create arrays if you remember, obviously the way I showed you just now, but you can also have commas if you want. That's another option for creating arrays instead of spaces, right? So if instead of having spaces, I simply add a comma between each of the numbers, then I have the same effect as before. Okay, by creating the different arrays, the different numbers in the array, right? So and notice one thing here, that this 7.9 is created here, right? And automatically, since I had a decimal number here, it assumed all the other numbers were also decimal. If I didn't have a decimal, if I, for instance, do just 7, see how the numbers are automatically stored as integers, but since I had added a 7.9, then it's just assumed that everything else was also, it gave everything else a decimal value. Let's look at another example where you can, manipulate arrays in any specific ways. There's another function, a special function that's called the once function, just like you have the rand, right? Creating rand numbers, random numbers. We also have the once function, okay? And the once function creates, as you will see, a identity array or an identity matrix. In this case, it creates an array 1 by 5 of all ones in it, right? And I can do this for any size matrix. If I have a 2 by 2, it creates a matrix in this case of just ones. It's just a special matrix. Okay. So to be more specific, in this case, in the first case here, this is an array 1 by 5 where 1 is the row and 5 is the number of columns again, right? There's another function also very useful and very similar to this that you can use to create zeros, right? If you need an array of just zeros, I can create, just like I did the ones, an array of 3 by 3 zeros or whatever number you want. Okay, 8 by 8 of all zeros. And you can manipulate this. So let's say, for example, I'm going to create this X array of zeros, and I'm going to make it a 1 by 5. But this time I'm going to add 2. Okay, so we create an array of 5 zeros and then add 2 to each of the 5 zeros. So this will give me, you would suspect, right, a 1 by 5 of all ones. Okay, now this is the same thing if I do this. If I add 2 plus zeros, because the order in which I'm doing this doesn't affect the result. Sorry. You can tell my typing is not very good. All right, so it's the same thing, right? Whether I put the 2 at the end after the 0 function or before, I still get the same result, right? And there are many ways to achieve the same goal, right? You can manipulate this ones and zeros functions to create any kind of arrays that you want. For instance, if I have ones 1 by 5, and I'm going to multiply by 5 and subtract 3, then you can see that I get the same result, right? So it's not that, you know, this is the only way you can do it, but, you know, you can take functions like the ones or the zeros and manipulate it any way you want to obtain the result that you want. Okay. For this last example, we first created an array of 5 ones, then we multiply them all by 5, so now we have 5 ones, and then we subtract 3 from each of them, so now we have the 5 twos that we wanted in the first place. Okay. Now let's continue with a few other operations. Let me clear the screen here. So let's say I have an array X with the following elements in it. I have 1, 7, 9. I'm going to add -3 and 0.5, and I'm going to call this array X. Okay. I'm going to, of course, save it in a variable. So now I can look. I showed you last time how you can use who to look at the size, for instance, of X. Right? It gives you the size and the number of bytes and all of that, and the type of number that is saving. And if you just do who X, you don't see much information other than you do have a variable X, right? The who S gives you all the details about that variable at that point. Another way of finding information about the array is, if, for instance, if I look at the length of the array, it'll give me the specific length. Okay, in this case it's 5. If I look at the size of the array using the function size, it'll show me, you know, the size of the array. In this case is 1 by 5, right? So those are special length and size, useful functions that will give you information about size and length of the array. Okay. Now, one thing to remember, I don't think I made it obvious, but if you program in C, you remember that when you program in C, the index of the first array is 0, right? The first element in the array has an index of 0. Well, in MATLAB, the first index of the array is always 1. There's a little difference about that, right? So, and I showed you this before, right? But just want to remind you. So x1 obviously is going to be 1, right? And if I do x0, it's going to give me an error, okay? Because it has to be, you know, the first index has to be 1, okay? So in MATLAB, all the indices also have to be positive integers, okay? If I do, obviously, you know, if I do x2, I will get the second element of the array, right? And if I do x again to remember where those numbers are, right? I can simply retype x and that show me the array again. And as we suspected, the second element of the array is 7. If I do a negative index to find or try to find that index, it doesn't work. Okay, so the indexes have to be *1 and has to be a positive number. Also, if an array is too long, you don't exactly know what the last element in the array is, you can use the n inside the parentheses, and it'll show me the last element in the array, which in this case is 0.5. So that shows me the last element. So using n as an array argument implies that you're looking for the last element in that array. I can also, you know, if you think about it, right, since I know the length of the array, right, by using this function, right, is 5. The length of this array is 5, right? Then, you know, implicitly, if I do x, just instead of retyping it, I'm going to look at it in the function here. So if I do length, but instead, you know, since I know what the length is, right? The length is 5. So doing this also gives me the same result, the last element in the array, right? Because remember, length of the array gives me the whole, you know, size of that array, the length of that array. So the last element is always going to be that number, in this case 5. So it's the same result. Another way of using this, okay, is if I can access elements in the array in a particular order that I want. Okay, I can access, for example, let me define this. All right, if I do parentheses and then bracket 1, 2, 4, close those brackets, right? I can then, at one time, I'm accessing the first element of the array, right? The second element of the array, and the third element of the array. I'm sorry, the fourth element, right? The first, the second, and the fourth in this case, right? And the fourth element is -3. So that's another way, again, of accessing specific elements in the array that you want and getting to the information that you need. Another way of accessing elements in the array are, for instance, using the n. In this case, I'm going to type x. I'm going to go in increments of 2, since I'm using, and then I'm going to do up to the n, whatever the n is. So I got caps label. So let's do this again. So I have x, 1, 2, to the n. And then what I have again, if you notice, I have the first element of the array, right? Because that's the starting point. And when I go to the n, so I'm incrementing the index by 2, right? So again, the first element of the array is 1. I'm going to increment the index by 2. So I'm going to go 2, 3. And so the third element of the array is 9. And when I go to the n, in this case, the n is just, you know, only have this number, this 5 elements in it. So that's, I reach the n, because incrementing the index by 2 brings me to 5, which happens to be the n. So accessing information like that is very important. It's a very important feature and very useful to manipulate an array. So I can do the reverse also. If you notice, I can do, if I do x and n from the n of the array, and I'm going to decrement by 2, going down to the first element in the array, right? So as you notice here, I started at the n, and again, I'm going down by 2 indexes, down to the first element in the array. See, very useful for manipulating numbers within the array and accessing them using the index. Be careful, because now, you know, parentheses allow you to get, you know, use indexes, right? And brackets allow you to use or to manipulate the numbers in the array. Like in this case, the brackets mean the content in that array, and in this case, the indexes are within parentheses. Okay, let me clear this now. You know, that's, again, that's how you can manipulate elements in the array. Let's do another one here. I'm going to define x as an array with the following elements: 3, 8, 9. I'm going to have -3, minus 6, 0, minus 1, 0.1, and 0.3. And so I have, if I want to know what the size is, right? Remember, I can simply do this as a 1 by 9. So I have 0.1, 0.3, let's see, 3, 8, 9, minus 3, minus 6, 0, minus 1, 0.1, 0.3, right? Those are the elements I have, and it's a 1 by 9, so I have 9 elements in that array, right? Let's say that I want to replace the values of that array at all even locations with a number minus 4, right? So that's our challenge. Let's see if we can do this, all right? Replace values in X by minus 4, but only at even locations. And that's the task, right? That's the little problem we have. So how would you do that? You want to replace values in X. Okay, this is X. By minus 4, but only at even locations, meaning that I want to replace this one, right? Because this is index number 2, index number 4, 6, and 8. So those values, I want to make them equal to minus 4. So you can stop the video. I'll show you the solution. Okay. So remember, I want to access the different indexes, right? So I want to go, you know, in an even way, right? From until I reach the end of that vector. So since I want to replace every second element, then I want to start at 2, right? And I want to increment by 2 until I get, and let me just assign, because I'm using that vector, right? So I'm going to start at 2, and I'm going to increment or the set by 2 until I reach the end. And so I'm accessing, with this statement right here, I'm accessing every second element in the array starting in index 2, right? Starting in index 2. So I'm going to go 2, 4, 6 until I reach the end. And for every element that I'm accessing, I'm simply going to replace it by the number minus 4. And so now the new array, as you can see, has been replaced with the minus 4 at every even location. All right. Again, it's just a matter of, you know, manipulating arrays, which is something that you're going to have to just practice, right? With this different, there's so many different variations of this. I'll show you another example. And for this one, let's say you want to replace the last 5 numbers in X with the number 2. So let's try this one, right? In this one, we want to replace the last 5 numbers in X. We want to replace it with the number 2. All right, so how would you do that? Okay, again, I give you, and by the way, these problems don't have just one solution, okay? They may have different ways of doing it, right? For one thing, we want to do this in one single statement, right? Because you can do this in other ways by, you know, we're doing like a for loop. We haven't gotten into that yet, but doing like a little for loop or something like that, that will allow you to do this. But we want to do it in one single step. So since I want the last 5 numbers, and this may not be the most elegant way, but I'll show you one way here. And so I'm going to get X, right? And I'm going to get to the indexes, but I'm going to define those indexes by getting to the elements of the array, right? So since I want the last 5 numbers, I'm going to take the last number and I'm going to subtract 4. Then I'm going to take the last number, then I subtract 3. And this is just the index, remember? And I'm going to subtract the 2 and 1 until I get to the end, right? So I'm going down 5 in that way, right? And then simply going to replace that, right? Because that I'm accessing the indexes, right? By doing this, right? The elements in the array, you know, the 4 before the last one, and then down to the last one, which will be the end one of those. Those are the 5 last numbers in the array, and I'm simply going to assign 2, right? And so that will do it. As you can see, the last 5 elements in the array are now 2 from this expression, right? Which we had the last expression we have for X was this. All right. So, like I said, there's more than one way of doing it. You probably do it some other ways, some other way. Another way that I could do this also is if I take just simply the indexes, right? If I go from the one before last, or the n minus 4, and till I reach the end, right? Instead of, you know, subtracting 1 and 1 very explicitly like I did this, I can just do the column, and as I know, this will bring me from this point to that point in steps of 1, right? Because by default it's going to be 1, and I'm simply going to assign 2 to it, and it's the same result, as you can see. In other words, if you want to see this, I can assign another number so you can see that it works. In this case, I assign 8 to the last 5 elements in the array. Another one, let's say you want to replace the first 3 numbers with minus 5. So let's try another one here. Replace the first 3 numbers with a 5. Okay, try that one. Again, pause the video and you can try it. Okay. So this time, the first 3 numbers in the array. So this is what I have as the last contents in the array. So I want to make these 3 numbers equal to 5. All right. So what I can do is, again, look at the index from 1 to 3 in steps of 1 again, and I'm simply going to assign 5. All right, very easy. That one was easy, right? Let's do one more. Let's replace the last 4 numbers with the first 4 numbers. You're doing a swap here. All right, you want to replace the last 4 numbers with the first 4 numbers. Remember, we have this, at this point, this is what we have in the array, right? So you want to replace the last 4 numbers with this. All right, so you want to bring those numbers into here. So again, give you a minute, pause it, and then I show you the solution. So since I want to go from the last 4 numbers, one way of doing this will be to, again, just swap in defining the indexes. I'm going to go from n minus 3 to the n, right? That simply is defining this right here, the last four numbers. And I'm going to replace those last four numbers, but by the first four, which, as you can see, those are not that difficult to get, right? Because they're going to replace from 1 to 4, right? And as you can see, those numbers were replaced, right? These four numbers have been replaced by these four numbers in the new array. Okay? Okay. Now let's use the same, let's go back and look at our original X. Let's see if I still have it. Yeah, this one. Let's use this one again, okay, for the other example I want to show you. And in this example, let's try this, right? We want to swap the first, three numbers with the last three numbers. All right, so again, give that a try, okay? And obviously, there's more than one way of doing this, right? So one way I'm going to do it is I'm going to do it in steps, okay? I'm going to first save the first three elements of X in a temporary variable, right? So I'm going to call that temp, and I'm going to save the first three elements in X in that variable temp, okay? I'm also going to replace the first three elements in X with the last three elements in X by doing this. I'm going to take X, the first three elements, and I'm going to replace them with this, the last three elements in the same vector. Right? This will begin. This is the last element, right? I'm going from the last element minus 2, last element minus 1 until I get to the end. And I'm going to replace that with the first elements in X, right? And then finally, I'm going to copy the original three numbers, which were at the first three locations, to the last three locations, right? So the last step will be n minus 2 to the n. And I'm going to bring my temp that I created in the first step, and that will do it. So if I type X now, as you can see now, X has minus 1, minus 1, 0.1, 0.3, minus 6, 0, 3, 8, and 9. So I swap the first three numbers, right? The first three numbers with the last three numbers, right? The last three numbers are now this, 3, 8, and 9. And I brought these last three numbers as the first three numbers in the array, right? It's the swap, right? I swap of this 3 in the back to the front and this 3 in the front to the back of the vector. And so this was done by doing, this little three-step process. And again, it may not be the only way you can do this, but you can try other ways of doing it, and probably more efficient than doing it in 3 steps. Okay. All right. A couple more examples. Let's say I have X now equal 1, 2, 8, and 10. Okay. That's my new X array. And I want to now do this. I want to replace the first and the third elements with two new numbers. I want to take the first and the third element. I want to take the 1 and the 8 in this case, which is what the vector has, and I want to just put in a new number. So let's say I want to put minus 11 and 55. Okay, just to choose something. All right, so let's do this one. All right, so one solution will be, again, I'm just taking, this is easier actually, because I'm taking the first and the last and the third element. So I'm going to take the index, right? I'm going to access the elements 1 and 3. Because since I have parentheses, I'm accessing that as an index, right? And you can see what I'm accessing here, right? I'm taking the 1 and the 8, right? See that? This first statement is just taking the 1 and the 8. So what I really want is I just want to replace those two by the numbers I've chosen, which was what? Minus 11 and 55. Okay, so now if I look at X, then the last two numbers have been replaced, right? Let's see. Yeah, okay. Because if you look at this, this is our original X. Now it has 55 and 10, right? All right, let's do a couple more things here. Let's take X again. Let's see, where is X? Let's define X like this again, okay? And now let's do, I want to replace the first and the third element with two random numbers between, let's just say 3 and 5. All right, so I want to replace the first and the third number, the 1 and the 8 again, with two random numbers between 3 and 5. All right, so I'll give you time again on this one. Okay. So one way, again, remember, there's not a unique way of doing this problem. The one way, again, I'm going to access the elements that I need, the first and the third. As you can see, if you do this, you're accessing the first and the third. If you want to double check. So to that, I want to make the number a random number between 3 and 5. So I simply going to multiply, right? I'm going to take the random number, since this is a 1 by 2, I'm going to multiply by 2, and I'm going to add the number 3 because I want that random number to change or to, to vary between 3 and 5. And so I'm taking, as you can see, 1 and 3, right, are two numbers between 3 and 5. If I do it again, obviously I'm going to get different numbers, right? Right? See how I get different numbers. Of course, the 2 and the 10 don't change, right? That's not what I intend. But the first and the third keep changing to any random numbers. If I run this again, you'll get two different random numbers every time, right? Because that's what it is, a random number between 3 and 5. right, between 3 and 5. Okay. Let's do one more. Let's do one more exercise here. We want to add the first three elements to the last three and save them in a variable, let's call it z. Right? So I want to add the first three elements to the last three and save them to a variable that I call z. Okay. All right. So if I take, again, one solution could be, right, first of all, I'm going to assign the result to this variable z, right? So I'm going to take the elements from one index to 3, and I'm going to add to that the elements in x from n to, or rather, since I'm going from the third element, I'm going to go from n minus 2 to n, right? Because that's what I'm trying to swap. And that's it, see? I've taken the first three elements to the last three elements and save them in z. Okay. And let me repeat this with the x that I had previously, so we can have more elements and see. Yeah, let me use this x, right? And I'm going to repeat my last statement here, and then see what happens. See? So it, I'm saving the result, right, into the variable z, and by adding the first three elements to the last three elements, and I'm just saving the result in z. All right. First, 3 minus 1 is 2. 8 plus 0.1 is 8.1. 9 plus 0.3 is 9.3. I'm adding the first three elements to the last three elements and putting the result back in Z. All right. Also remember that at any point you can use the function disp to display the values of any variable that you want, right? See how before I kept, to look at the values, I look back into the different commands that I have, but you don't have to do that. You can, if you can just use disp and display any variable that you have defined. For example, we have previously, temp, for instance, is still in memory. So I can still, if I don't remember what temp is, I can use disp and I can recall that value. All right, let's see. Another one that is important that we can use later, we're going to use that later, is the input function. Input. With input, you can you can add information interactively. Okay, when you're doing any kind of value, right? So if I say, for instance, by using input, you're going to put something on the screen, right? Or in your script, and you're going to add that information. but that information has to go somewhere, right? If I do input, and I'm going to use single quotes, right? And I'm going to say enter a number between 1 and 10. Okay, and I'm going to close that single quote, right? Well, if I do that, okay, see, it tells me, it shows you on the screen what I had in single quotes, right? So that's a way for you to enter information and making your program interactive. Now, at this point, I'm not saving anything. So if I enter something, if I enter a number 6, for example, by the way, there's no spaces in there. I'll show you something in a minute. Since I haven't assigned a variable to it, it goes to the A and S by default, right? So two things I can do. I can, first of all, I can assign whatever result I'm going to input to a variable. So if I chose T, then that variable that I define is going to save the information that I'm going to put in here. Another thing that I can do, and later I'll show you way of formatting the different inputs. One is if you use a \n, it's going to create it's going to move to the next line, so I can enter that information on the next line. I can also have a space. I do space, and I'll do both so you can see. So if I do this now, see, it's asking me enter a number between 1 and 10. Well, it's not going to do anything until I enter that number and I press return. So if I press 9, it's just going to sit there. It's not going to do anything. I have to press enter. And now, as you can see, T has the value 9. And it's showing because I didn't have a semicolon at the end, right? You know that. Now, if I do the same statement, but now I'm going to add the \n, you see what happens. Okay, I'm going to run it again. But this time, see how the result is going to be entered in the next line. So if I do 2, see how it's in the next line. Okay. If I do 2 again, T is going to have the number 2. See? So input is a very useful function that you can use to create interactive scripts and enter information interactively like that. We're going to do that later when we do a script. We're going to use that function to enter information. All right. Another function that I want to introduce is linspace. Okay. By the way, when you use these functions, there are two things you can do. If you don't, if you want to get more information on any of the functions, you can use help and the name of the function. So if I do help input, it's going to show me, okay, what do you want? It's going to tell me, the information that it has on input, and it's going to reference other places where you can find more information about input, right? So that's very useful. If I use linspace, which is the other function I wanted to introduce you to, okay. Another thing I can do, if I double click on that function, or if I right click on that function, and I can just simply click on help on selection, it's also going to try to find information in that function. So if there's anything that you don't recognize or want more information on, you can either type help in the function, or you can select it and just see, click on help on selection, right? And it's going to show me all kinds of help on the item or the function that I want. So linspace is a function that is used to initialize a vector of equally spaced values. For example, if I do linspace 0, 15, 10. The way this works is that it's telling me that I want to generate a vector from 0 up to 15 with 10 values, okay? So 10 equal space values from 0 to 15, okay? So it's going from 0 to 15, and it's going to give me 10 values equally spaced, okay? That's what lean space does, okay? It's also another very useful function. Let's try it again. Now let's see if I change. I'm going to go from 1 to 25, and number of values, let's say I want 5. So now I have 5 values from 1 to 25. See, from 1 to 25 in you know, equally spaced, right? So the space it creates, it depends on the indexes that you have here. Another example, let's say I want from 10 to 100, and I want 25 values, okay? 25 values from 10 up to 100, right? Equally spaced. Very useful, nice function that we can use later. So that's for linear data. There's also a function log space, which is the same idea, but it creates a logarithm spacing instead. So for instance, if I have log space 0, 2, 10, it's going to create 10 numbers from 0 to spaced logarithmically, right? So 10 numbers or 10 numbers that are logarithmically spaced with, you know, the log of from 0 to 2, right? Or the number, in other words, they generate that log of 2, right? Because, you know, log of 100 is 2, log of 1 is 0, and so forth. But it generated 10 numbers like that, but this time the logarithmic spaced in between, right? So that's another useful function. Remember that when you use when you keep using these variables, right? When you keep creating these variables, in this case, I didn't generate or I didn't assign anything to any variable to that result. And if I don't, then there's no way for you to get back to that result, because right now it's temporarily storing this answer variable. So unless I assign it, then, you know, it's not going to be stored anywhere. And now I created that new y variable that has those values stored right here. Okay? So next time we're going to use a lot of this information that we have learned about, and we're going to start writing our first script. Okay, we're going to go into the editor, and we're going to start writing scripts and see how they work. So I'll see you in the next lecture.